Our next speaker is Dr. Niamh Gill, speaking about hip loading when in step length, effect of stature. And please, if you've got any questions, please do add them to the chat.
Hi, good afternoon, everyone. Thanks, Karina, for that introduction. And I'm a postdoctoral researcher at the University of Salford, and I'm currently working on a project that is in collaboration with the Ministry of Defence and the Optimising Physical Performance research team based at Army HQ. So what I'll be presenting today is only a small part of a much bigger project. So I'll be focusing on hip loading when enforcing speed and step length, the effect of stature and sex. So just to start with, we know that the number of women in the Army is increasing. And as of 2018-2019, women currently serving and women entering basic training can apply for infantry or ground close combat roles. And the biggest physical challenge facing women applying for these roles is the requirement to lift and carry heavier loads for longer periods of time. Therefore, there is a need to understand the biomechanical effect of heavy load carriage for both men and women, and whether women in these arduous roles are inherently more at risk of injury than their male counterparts. So, military personnel are also required to march in step at a fixed pace and subsequently a fixed step length, often for prolonged periods and whilst carrying heavy loads. This marching in step may require individuals to deviate from their preferred gait pattern, which has been associated with an increased risk of lower limb injuries. There's been a little bit of research into this before, and it's been shown that the anterior-posterior ground reaction forces increase as step length increased, but there was little to no difference found in the vertical ground reaction forces. However, it's worth noting with this study that there was relatively small changes in step length considered, only plus or minus 5 or 10%. And with the range of statures in the military, individuals could be required to change their step length by up to as much as 30%. Another study looked at peak sagittal plane joint moments and showed that they increased as step length increased. But with this study, they looked at they used a nominal value of step length across their entire participants. And this was chosen to be representative of a normal healthy adult. So it may not account for individual differences within their own cohort, but they did look at differences of up to plus or minus 20%. So we know, we expect that many factors play a role in the risk of injury in military population. But to mitigate this risk, we need to develop novel sex-specific strategies for optimizing load carriageability. And we need to understand how these factors influence lower limb biomechanics. Within the broader scope of the project, we're aiming to explore the majority of these factors and their effects on lower limb biomechanics in both civilian and military populations. However, for this presentation, I'm just going to consider these four: sex, speed, step length, and stature. And for this presentation as well, I'm concentrating on a civilian population. So although these previous studies have explored how changing step length affects lower limb biomechanics, the studies considered only minor changes in step length, or they use this nominal value of step length. So the true effect of altering preferred step length on hip joint loading remains unknown. So we wanted to look at answering this question: does changing speed and step length affect hip joint loading during unloaded walking? And what are the effects of sex and stature? So for this study, there was 37 participants, 19 female. And again, these were civilians and they were walking unloaded. We collected synchronized kinematic and kinetic data as participants walked over ground at 1.4, 1.6, and 1.8 meters per second. A metronome was used to provide audio cues, and targets were projected onto the ground as visual cues. We determined subjects' preferred step length using a treadmill in a previous session, and then targets were projected at 0, plus or minus 10, plus or minus 20, and plus or minus 30% of their preferred step lengths. We used timing gates to monitor speed, and we used a linear mix model to determine the effects of speed, stature, sex, and step length. So this is just an example of the ground reaction forces for the different step length conditions and just at a single speed. So it's just to give you an overview of what the data looked like. The legend on the right shows you the different step lengths, so the change from preferred. Blue indicates the shortened step lengths and purple represents the lengthened step lengths. Steps increased in length going from light to dark. So what's interesting to look at here is in the anterior posterior, the ground reaction force peaks increased as step length increased, which I think we'd kind of expect. But in the medial lateral direction, the medial peaks increased as step length decreased. And in the vertical direction, the peaks look to be fairly similar across all of the step length conditions. So this is quite a big table, and I'll go through it in a little bit more detail and pick out the kind of interesting points. But just to start with, the upward facing arrows imply that there was a significant increase compared to 1.4 meters per second or the preferred step length. So they were the reference values. And then the downward arrow implies there was a decrease compared to 1.4 or the preferred step length. So in terms of the ground reaction forces, what's interesting to look at is there was a significant effect of both speed and step length on the peak anterior posterior ground reaction forces. And there was also a significant effect of speed on the peak vertical ground reaction forces, but only the peaks at plus 20% and plus 30% were significantly different to the preferred step lengths. So really when the people were overstriding quite a lot. And the other thing to pull out of this was that there was a significant effect of sex on the peak medial ground reaction force, and there was no other effects of sex in the ground reaction forces. So this is an example of the hip joint angles. And again, the line convention was the same as before. What's interesting to show here is the flexion extension increased as step length increased, but we would expect to see this. The adduction appears similar across the step lengths, but the abduction angle increased as step length increased. And in the transverse plane, both internal and external rotation appeared to increase as step length increased. So again, I'll go through this table in more detail, but just overall, there was a significant effect of speed on all the peak hip joint angles during stance, except for the peak hip internal rotation. There was a significant effect of changing step length on peak hip joint angles during stance, and there was no effect of stature on any of the peak hip joint angles. So I think the most interesting finding here is that there was a significant effect of sex on the peak hip adduction angle. And we think this is probably important because we know that increased hip adduction angles have been associated with injuries in runners, as well as patellofemoral pain and iliotibial band syndrome. And these are all common injuries within a military population. So this is just an example of the hip joint moments. So again, the line convention is the same as before. And just to draw your attention to the peak extensor flexor moments, which both appear to increase as step length decreased. The abductor adductor moments, which appeared to increase as step length increased. And the external rotator moment, which appeared to increase as step length increased. So if I go on to the next slide, again, I'll go through this table in more detail, but just to note that there was a significant effect of speed and step length on all peak hip joint moments. So I'll just pull out a couple of details. There was a significant effect of stature on the peak extensor and adductor moments, with peak moments increasing as stature increased. And there was also a significant effect of sex, with female civilians having larger peak abductor, adductor, and external rotator moments than male civilians. So these findings have important implications for military training and operations. The requirement to march in step means that many individuals will be required to change their walking gait from preferred. This is more likely to affect women, as women are generally shorter than their male counterparts and therefore are more likely to have to extend their step lengths beyond their preferred range. We also know that sex differences in joint moments might be reflective of anatomical variance or potentially differences in strength or neuromuscular control. But it's important to note that these differences might also partially explain the differences in injury prevalence that we see in military personnel. So we know that female recruits are twice as likely as male recruits to develop an MSKI injury, so a musculoskeletal injury. We know that female recruits are 3 times as likely as males to develop a stress fracture, and female recruits are 10 times as likely as males to develop a hip stress fracture. So as I mentioned at the beginning, this is a much bigger project, and what I presented today is just a small part of it. So what we're also looking at is preferred walk-to-run transition speeds, preferred spatiotemporal parameters, and isometric strength differences. And then we're looking at all of this within the idea of load carriage as well. So that's it from me today. Thank you for listening.
Thank you very much, Niamh, for your presentation. I was just wondering, obviously the military is quite a traditional and I can't think of the word, but things have been going there for a long time and things are probably, I imagine, quite hard to change. And have you found that the uptake of the results has identified any changes to training or practice, or are you waiting for those kind of alterations to happen in future?
Yeah, it's a kind of key question. We're still in the process of delivering the project to the Army, so we don't know what the uptake of the results is going to be. And there is some of the findings that we've, some of our findings actually reflects what they are trying to do already within the Army and training. But this will just provide a little bit more evidence, so people higher up in the command can have something to look at to say that this actually has to be done, as opposed to a personal trainer just saying that we think that this would work. But yeah, you're right. It is a very traditional system, so we're not entirely sure how much it's going to be taken up, but all we can do is look at the science and recommend based off of that.
Okay, thank you. We have another question in the chat, and it's asking how realistic are the extremes of step length and cadence conditions that you've included in your study based on female anthropometry, and are they realistically going to encounter these extreme conditions?
So we based the step length changes off of looking at the realistically or the tallest male versus the shortest female. So there is a height restriction on recruits in the Army, but if you looked at one of the shorter females versus one of the taller males, then at that extreme you could be asking people to change by up to 30%. So it's probably rare, but it is possible. So we wanted to look at those extremes, but realistically you're probably looking more at around the 15 to 20% within one group or one regiment.
Okay, I think we've got one more question, Niamh. Sorry, you've ended up with quite a few, but you've got a little bit of time left. So Malcolm's asking, it's not just about the increase in load that's the problem, but the sum total of loading over time. I'm wondering how that could be investigated.
Yeah, that's true. One of the biggest things is that the soldiers could be marching with these loads for over 4 hours. So obviously over time, that's going to be a massive cumulative effect of loading. We are going to be doing another study, hopefully in the new year, that's looking at a fatiguing effect. So we'll be having soldiers marching or walking on a treadmill for about an hour. So we're going to try and look at pre and post fatiguing exercises to see if we can see any differences in that. But yeah, in field, they could be looking at more like 4 hours as opposed to an hour or 40 minutes.
Thank you. It sounds like there'll be some interesting future directions, so you can share those with us at the next virtual live event of the research group. I'll hand over now to Sibylla for our next presentation.